In the previous program, you implemented the simple line tracking behavior on your robot, which allowed it to track a line forever. But tracking a line forever isn't always appropriate. In the grand challenge, the robot may need to track a line for a section and then do something else like turn or stop. In our program, the three if statements are what allow the robot to adjust motor speeds and track the line. The while loop is what controls how long the robot performs the line tracking behavior. So to keep the line tracking behavior from running forever, all we need to do is change the condition of the while loop so that it's based off of something else, like a timer or sensor. In this lesson, we're going to modify the line tracking behavior so that it repeats while a certain number of encoder counts haven't been reached. Start by opening the simple line tracking program and saving it as lineTrackForDistance. Now remember from the previous lessons that the shaft encoders monitor the rotation of the axles or shafts that pass through them. The motors turn those axles and the axles turn the wheels, so the shaft encoders can indirectly tell you how much the wheels have turned. Knowing how much the wheels have turned can tell you how far the robot has traveled, so setting the while loop to repeat until the encoder count reaches a certain point means that we can get the robot to line track for a set distance. Alright, so let's get programming. Before we can use the encoders, we have to configure them. Go to Robot, Motors and Sensor Setup. On the Digital Sensors tab, configure the right encoder in ports 1 and 2, and the left encoder in ports 3 and 4. Press OK to apply your changes and close the window. Since we'll be using the encoders to control the distance the robot moves, we'll need to make sure they start counting at 0. Add commands to clear the left encoder and right encoder before the while loop. Now the part of the code that controls how long the line tracking behavior runs is the condition of the while loop. Clear out the old code, and instead, we'll make this loop run while the sensor value of the right encoder is less than 1080 degrees, 3 full rotations. Compile and download, and run. The robot runs for a distance along the line and then stops. Great! Let's take another look at your code. As you may have noticed, we cleared both encoders, but we only actually checked one of them in the while loop. You'll need to be careful with this, because it's actually very difficult to measure distance accurately along a curve. The wheel on the inside of the curve travels a shorter distance than the wheel on the outside, which also means its encoder has rotated less. In our case, we chose to completely ignore the left encoder and only check the right one. This works, but keep in mind that in some situations, it may be more advantageous for you to use the left encoder instead. In this lesson, you learned how to control the distance your robot tracks a line using the shaft encoders. In doing so, you've also unlocked the ability to optimize motor speeds for different sections of a line tracking course. Move on to the next lesson to learn how to optimize your code for different types of lines.